Dear students, welcome to Gurudev Science College, Dharwad. Today, I am here to discuss you with the most important topic. The most of the students try to quit this topic, that is the part D. In the part D, you have two options with the physical chemistry and the organic chemistry. Now, I will discuss you with the organic chemistry how to solve the questions. The first question, so in your new pattern, the 42nd question will be from the organic part. Explain SN1 mechanism for the conversion of tertiary butyl bromide to tertiary butyl alcohol. My dear all, SN1, what it is going to represent? SN1, it is nothing but unimolecular nucleophilic substitution reaction. So in this unimolecular, so why it is called as unimolecular? Because the rate of the reaction is dependent on the alkyl halides. That means it is dependent only on the alkyl halides. If you come to the SN2 reaction, you will come bimolecular nucleophilic substitution reaction, because the bimolecular indicates here the rate is dependent on alkyl halides as well as the nucleophile. That's why it is the difference between SN1 and SN2. Now we shall move on to the mechanism, very important. So somehow you will get the two questions, either SN1 or SN2. Here in SN1 reaction, my dear all, please remind that you will come across two steps in this reaction. Yes, so the step 1 will be the formation of carbocation. Yes, so the formation of carbocation takes place by the consideration of tertiary butyl bromide. So here in the question they have already clear mentioned tertiary butyl bromide. So this tertiary butyl bromide undergo reaction forming the carbocation. Here the formation of carbocation takes place. This carbocation, it is considered as the slow step. The formation of cation, it is considered as the slow step, and also it is called as RDS, that is rate determining step. By this step we are formed the carbocation. This carbocation, in the next step we will go to the step 2. So what happens in the step 2? Here the carbocation is formed. This carbocation is to be attacked by the nucleophile. Attack of nucleophile. So my dear all, the nucleophile, it is considered as the negative part of the reagent. So whatever the reagent you are using, that is considered as the negative part. So consider the formation of or the attack of nucleophile. See, I have just taken the same step here for the attacking of nucleophile. Here you are going to attack the nucleophile. So nucleophile which is carrying the negative charge. Thus the formed product is the tertiary butyl alcohol. Our target is the formation of tertiary butyl alcohol. In the two steps we are taken the tertiary butyl bromide and we have formed the tertiary butyl alcohol. This question, that is 42nd question, it is divided to 3 parts, that is 2 plus 2 plus 1 or 3 plus 2, anything else, get ready for that. Here in the 2 steps, first is the formation of carbocation, second is the attack of nucleophile. You just remember the tertiary butyl bromide you have to take and you have to form the carbocation. So in this formation of carbocation, this negative part, the bromine is removed. The bromine is altered by the OH group. Thus we got the tertiary butyl alcohol, where you can complete the SN1 reaction with the mechanism. You can simply take the general reaction, that is the formation of the tertiary butyl alcohol, that is by the addition of NaOH. Here we are getting the product as the same, that is the alcohol, and the remaining sodium bromide is released because this Na plus and Br minus are acting together and the OH will attack with the carbon atom. Thus it is clear about the SN1 mechanism. My dear students, you will also get the question, the SN1 mechanism, why it is called as SN1. You have to explain, that is the rate is dependent only on the alkyl halide. Next we shall move to the next question, that is what is the hybridization of halogen containing carbon in the following. So vinylic halides, benzylic halides. My dear students, so somehow you have learnt the hybridization by taking the definitions. So what we can directly tell, vinylic halides or the benzylic halides. So ನೀವು ಹೇಗೆ ಕಲ್ತಿರ್ತೀರಾ, ಡೆಫಿನೇಷನ್ ರೂಪದಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಾ. ಬಟ್ ಇಲ್ಲೇನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಕ್ವಶನ್, ಹೈಬ್ರಿಡೈಸೇಷನ್ ಹೇಗಾಗುತ್ತೆ ವಿನೈಲಿಕ್ ಹ್ಯಾಲೈಡ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ benzylic halides ಅಲ್ಲಿ. So I will take the example. One example we can consider for the vinylic halide. So here this chlorine atom, that is the Cl group, that is the halide. This vinylic means the chlorine is attached to the carbon double bond. So here the carbon is having what type of hybridization? So hybridization, you already know that this hybridization is dependent on the number of atom attached to the each carbon atoms. So this carbon is attached by how many of the carbon atoms? Here one is attached, here another chlorine is attached, that is 2, another hydrogen is attached, that is 3. So we can get 3. For the 3 we can tell sp2, is it right? That is 1s and 2p orbitals, that is equal to 3. That's why here the vinylic halides undergo sp2 hybridization. In the same sense, benzylic halides. So you already know benzyl means the aryl. We can also call that as aryl halides. Yes. So this aryl halides, here each corners contain the carbon atom. So ಪ್ರತಿಯೊಂದು ಕೂಡ ನಮಗೆ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದೆ ಅಂತ ಅರ್ಥ, ಕಾರ್ನರ್ಸ್ ಅಲ್ಲಿ, ಹೌದಲ್ವಾ? This carbon is attached by another one carbon, this is another carbon, and this is another chlorine. So here 1 2 3. So another one is, that is the hydrogen. So total 4, that is sp3, 1s plus 3p, it is equal to 4. 4 resembles the sp3 hybridization. So my dear all, you have to be very clear, sp2, sp3 and sp. So these three hybridizations are going to be happen by the number of atoms attached to the each carbon atom. Each carbon atom ge ಎಷ್ಟು atoms attach ಆಗಿದೆ ಅನ್ನೋದನ್ನ ನಾವು count ತಗೊಳ್ತೀವಿ. So sp ನಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದೀವಿ? So if it is attached by 2 atoms, one carbon is attached by 2 atoms, it is sp. If it is 3, sp2. If it is 4, sp3. This is one of the shortcut to remember about the sp, sp2 and sp3 hybridization. Now coming to the next question. Give the equation to prepare ethyl chloride by using thionyl chloride. So here directly they are asking for 1 mark. So they are asking for the equation. My dear students, some of you are having the fear to write the equations, to write the reactions. Simply just see the sentences what they have given. Preparation of ethyl chloride. So our target is to prepare ethyl chloride. What we are going to use? Thionyl chloride. Thio means what we can call, it should contain the sulfur. Simply we are taking one group, that is ethanol anta ankollona. We are taking the ethanol. For this you have to add thionyl chloride, that is SOCl2. So by the addition of sulfur group, what is the product going to form? Here the OH group, it is going to release. Here the chlorine is, which is the negative part, thus CH3CH2Cl. What is our target? Formation of ethyl chloride. CH3CH2, it is the ethyl. The formation of Cl, ethyl chloride. Somehow what are the byproducts going to release? That is, one is Cl. One Cl it is used here, another Cl is balance. Here also one H is remaining. So HCl. What are the remaining things? Here one S is there, one oxygen is there, here one oxygen is there. We can write SO2. That's enough. Simply we can write the reactions and complete the products. So my dear all, don't hesitate to write the reactions. So by the reactions only you are going to get the 100% full marks. Just like the mathematics, you will get the assurance what is the product formed. Then coming to the next question, write the equation involved in the preparation of phenol from cumene. Very, very important question for the examination, that is preparation of the phenol from the cumene. What is cumene? You can call it as isopropyl benzene. It is also called as isopropyl benzene. Please note it down. My dear students, here it is very simple. They are asking the write the reactions. So it is regarding to the preparation of phenol. So while for the preparation of phenol, here from the cumene you have to take the structure of cumene. If you remember the structure of cumene, then it is very easy to write the preparation. Here CH3 CH3H. This is the structure of cumene, that is isopropyl benzene. Here we are going to oxidize, that is the addition of oxygen for the preparation of the phenol. Here by the oxidation about 100 to 130 degrees Celsius in the presence of oxygen. Dear students, just look here what I am going to do. By considering the structure of cumene, ಸೊ ಕ್ಯೂಮಿನ್ ಸ್ಟ್ರಕ್ಚರ್ನ ಇಟ್ಕೊಂಡು ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಆಕ್ಸಿಜನ್ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆ್ಯಡ್ ದ oxygen. Where we have to add the oxygen? So remaining part I will write as it is. Here is 1 CH3. Here also we are here also writing I am the same CH3. Okay, this is CH3, this is CH3, both are kept same. They are asking to add 2 molecules of oxygen and we are having the same hydrogen as it is. We can call it as cumene hydroperoxide, right? Then next what we have to do for this, so we are going to add the water that is in the form of H3O plus and heating continuously at 100 degrees Celsius. So our major product that is the phenol is going to form. Just we have used this part here by the addition of the OH group. My dear all, here the remaining part that is CH3 is remaining, another oxygen carbon and another CH3 is remaining and one part of oxygen is here. That is the product formed is phenol and the byproduct remaining is acetone. This is also for the 2 marks where you can clear the reactions by the formation of the oxidation with the cumene. 2 molecules of oxygen is added to the same part and also by the addition of H3O plus at 100 degrees Celsius the OH group is going to attach, the formation of phenol takes place and the remaining part is the acetone. Next, the very important question, how would you distinguish primary, secondary and tertiary alcohols by using Lucas reagent? Yes, what is Lucas reagent? Some of you are having very big question. What is Lucas reagent? The reagent which contains ZnCl2 and the combination of concentrated HCl. That is the combination of Lucas reagent. So their question is, how you are going to distinguish between primary, secondary and tertiary alcohols? My dear all, let's consider one organic compound and add the Lucas reagent. Okay, that is ZnCl2 plus concentrated HCl. So they are asking to write, to distinguish between tertiary, secondary and primary alcohols. Here there is the important strategy to use to distinguish between the primary, secondary and tertiary alcohols, that is the time about the turbidity. Yes, so in the tertiary alcohols, so here if you got the turbidate immediately, if the turbidity is formed immediately, it is considered as tertiary alcohols. Next, for the secondary alcohols, the turbidity formed after 5 minutes. After the 5 minutes, if the turbidity is formed, then for the primary, only while heating, if you got the turbidity, then it is considered as the formation of the Lucas reagent. So here we are distinguished primary, secondary and tertiary alcohols by the turbidity time. So by the addition of Lucas reagent, that is zinc chloride, to the concentrated HCl, the turbidity is formed. For the tertiary, if it is formed immediately, for the secondary after 5 minutes, for the primary it is only while heating. So this is the major reactions, major turbidity form you can consider for the formation of the, to distinguish between the primary, secondary and tertiary alcohols. Next we shall come to the next question, that is for 1 marks. Tertiary alcohols do not undergo dehydrogenation. Why? Yes, so tertiary alcohols do not undergo dehydrogenation. What is dehydrogenation? So you are having the two forms. One is dehydration, another one is dehydrogenation. So dehydration, it is the removal of water. Dehydrogenation is removal of hydrogen. Now the question appears, tertiary alcohols do not undergo dehydrogenation. Why? Because they do not contain tertiary carbon atoms, do not have the hydrogens. So hydrogens are not present in the tertiary carbon atoms. So tertiary alcohols means, for example, here the OH group is present. This is the tertiary carbon atoms. It does not contain the hydrogen atoms. Hence this tertiary hydrogen is not present. So tertiary carbon atoms do not contain the hydrogen atoms. Hence here tertiary alcohols do not undergo dehydrogenation. Thus that is the formation of the tertiary alcohols. Next, describe the manufacture of ethanol from fermentation of sugar, that is considered as molasses. So by the molasses, how you are going to prepare the or manufacture the ethanol? So concentration of the sugar. Here the fermentation of sugar. Fermentation means, what is fermentation? The release of the carbon dioxide. It is having the major role. So that is called as anaerobic process. So in biology you have learnt about this. That is anaerobic, in the absence of oxygen. Here the carbon dioxide is released. So here for the fermentation process, here we are using the sugar, that is C12H22O11. That is the sugar. It is undergo hydrolysis by the presence of water, in the presence of the enzyme called invertase. The enzyme used is invertase. It is going to split into C6 So here there is a formation of C6 H12O6 plus C6 H12O6. We can consider the formation of glucose as well as fructose. By considering again the glucose or the fructose, here we are using the another enzyme called zymase. So by the utilization of the zymase enzyme, you will get the product ethanol, and here the release of the carbon dioxide takes place. Thus the manufacture of ethanol takes place. Dear students, first we have taken the sucrose or the sugar component undergo hydrolysis in the presence of invertase enzyme. It is split into two forms, that is glucose and fructose. That glucose or the fructose undergo the fermentation in the presence of the enzyme zymase. Here the formation of ethanol takes place. My dear all, here we will get the confusion which enzyme to be written first, which enzyme to be taken next. So as per the alphabetical order, you can remind the first enzyme, the alphabetical letter I comes, so use the invertase enzyme. Next is the Z, use the zymase enzyme. The same question may appear in the examination with the topic surface chemistry. Just link this topic to the surface chemistry. So surface chemistry nallo ನೀವು ಇದೇ enzymes ನ ಯೂಸ್ ಮಾಡಿ ಅಥವಾ ಇದೇ ಕ್ವೆಶ್ಚನ್ ನ ನೋಡಿರ್ತೀರಾ. ಅಲ್ಲಿ ಏನು ಕಲ್ತಿದ್ರಿ, for the enzyme catalysis you are used these enzymes. Okay, next we shall move on to the next question, that is Williamson ether synthesis with example. So formation, so here there is a clear question has clearly told you have to synthesize the ether. So for the Williamson's ether we are taking the alkyl halide first, then we are adding the alkyl sodium oxide. So in the presence of heat, look here, so ether is the presence of R dash, right? Here we are having R, here the oxygen is present, R dash is present, R dash. So the remaining thing is the NaX. My dear students, you can consider the removable part or you can consider the target product. Anything you can get, you will get the final product for the ether synthesis, and this you can correlate with the SN2 reaction mechanism. That is, here the SN2 reaction, it is directly going to for the formation of the product by the inversion of the configuration.